Hello everyone, in this video we will present and demonstrate in live how you can deploy stablecoins and other custom ERC20 tokens on a Bitcoin-IPC subnet, and most importantly how you can benefit from the built-in bridging capability of the Bitcoin-IPC protocol. Let's assume there are 3 Bitcoin-IPC subnets, and as an issuer we want to use subnet A as the home subnet of our new contract, which means we will be able to mint and burn only on subnet A. The first step is to register the token on subnet A and declare it as bridgeable. The token obtains an address, and let's say for the sake of the example this is USD BTC stablecoin. The next step would be for the home subnet to announce that a new contract has been deployed, a new bridgeable token exists now. This helps us track several things on Bitcoin. The first is the token identity of all bridgeable tokens. The second is the total supply that exists of every token. And the third is the balance that every subnet holds on our tokens. In our case, subnet A holds the whole initial supply of USD BTC, while subnet B and C hold 0. When this message is finalized on Bitcoin, the other subnets, B and C, they learn the identity and the balances of this token. And observe here that as an issuer, we do not have to deploy anything on the other subnets. The process for supply adjustment is similar. This is what happens when, as an issuer, we call mint or burn for our stablecoin. The home subnet again announces all these mint and burn events. Bitcoin is tracking their balance by adding or subtracting the minted or burned event, and like as before, every subnet is monitoring Bitcoin and updating the balances. The most interesting flow, however, is what happens when a user wants to transfer our stablecoin. Let's assume that the user wants to transfer 10 USD BTC from its address on subnet A to an address in subnet B. The first step would be for the home subnet to batch all outgoing transfers. And this includes transfers in USD BTC, but any other token and also the native outgoing transfers. These are batched on a message which is posted on Bitcoin, and for every token, this includes the deltas. In this case, subnet A is sending 10 tokens and subnet B is obtaining these 10 tokens. Once this message is finalized, like before, the validators of all other subnets are monitoring. They obtain this message, they verify its correctness, and they update the balances. The invariance here is that all subnets must have positive balances on the tokens. If that's not the case, the validators simply ignore the message on the Bitcoin L1. And when this happens, what we call lazy deployment takes place. The contract is created on the first incoming transfer on every other Bitcoin-IPC subnet. In this case, there will be a wrapped representation of USD BTC on subnet B with the same name, symbol, and decimals as home, because the subnet knows this information from Bitcoin. And now the subnet can actually mint the 10 received tokens to the recipient address. To sum it up, we have seen that Bitcoin tracks the supply and the balances of every bridgeable token. In this case, there could be a second token for which right now maybe only subnet B holds a positive balance. And as we have seen in previous videos, also the wrapped Bitcoin is tracked by the Bitcoin-IPC protocol. This allows us to achieve what we call the firewall property, which requires that a subnet can at most send out the amount of a token that was legitimately sent into it. So if there is an evil or a compromised subnet, which holds, for example, only 5 million of a token, and it tries to send out multiple transfers that total to 1 billion, for example, then the recipient subnet will reject these transactions because they are tracking the balance of the S-evil subnet, and they know that that it doesn't have as many tokens. And with that, let's jump into the live demo. Let's look at the setup. We have already created 2 Bitcoin-IPC subnets which are running, and we are here querying their height. And as we know from previous videos, the Bitcoin-IPC subnets anchor and communicate over Bitcoin. And for the sake of these demos, we are using the regtest network for this. So we are also querying and showing its height here. Let's start by actually deploying such a contract. So what we have here, I have prepared a script which does 2 things. The first is to deploy a standard ERC20 contract using this name, symbol, and decimals. And for the sake of an example, we can assume that we are an entity that wants to deploy a stablecoin on one of the Bitcoin-IPC subnets, right? So we could be deploying the USDT BTC stablecoin. We also specify the initial supply, we specify the RPC where we want to connect. And the second thing that this script will do, it will call a contract which lives on this gateway contract of every Bitcoin-IPC subnet and mark this contract deployment as bridgeable. We will see later how this allows the protocol to transfer the new contract to any other subnet. So let's go ahead and submit it. Here, the deploying of the of the ERC20 contract is happening, and we can see that this is the address, and we get back some more information here. For now, we want to keep the address here. So what is happening behind the scenes is that the validators of this subnet are creating a message, they sign it, they post it on Bitcoin, and with this way, any other Bitcoin-IPC subnet can know and can verify that a new contract with this address has been created on this subnet. Now, on every Bitcoin-IPC subnet, there is another contract which we can call using this here command line. As we said, every custom contract has what we call a home subnet and a home token address. The home subnet is the subnet where it's native, where it's created, and where the issuer can mint new tokens. And the home address is just what we took back from the deployment. So actually, if I run it now, it will complain that we haven't set the token address because it was not known before. So let's go ahead and define it. And now we can run again the same command. And what is happening? This is querying the subnet with a query that says, give me information about this token, right? And the subnet responds, it tells this is the name, this is the symbol, the number of decimals. And it's telling us that this subnet is the token's home subnet, so there's no wrapped contract. It is natively represented in the subnet. We can also use a similar query. It's exactly the same actually, but now we are sending it to subnet 2. That's the second subnet that we have created and it is running. As we said, subnet 2 is monitoring Bitcoin and it already is aware that a new contract has been created. So you can see that this subnet knows, again, the name and the symbol. It knows what the home subnet is, it knows what the home token is. And as we can see here, the cool thing about Bitcoin-IPC is that for now, since nobody has breached this token to the subnet 2, it says that there is not yet a wrapped version of the contract deployed. We will see just in the next step what will happen, how this will change if we perform a cross-subnet transfer of this new contract. But before we continue, let's check on MetaMask the balance of the users and the issuer for this new contract. So here I have created an account for the issuer. This is the same private key that I'm using to deploy the contract. And as we can see, this is an old token that I had created earlier. We can now go here, import the tokens. We can use the address that we just obtained. And here we are. The balance is 1 million of these. And this is held only by the token issuer. We can, as a first step, send some balance from the issuer to user 1. This is a standard cast command that I am submitting. Once this goes through, we can now switch to our user 1. Also import the token here. And now we can see that this user has 10 USD tokens. We are still, remember, on subnet 1. And let's now see what will actually happen if we try to perform a cross-subnet transfer. For this, the protocol provides a specific command line that we can use. It is this one here. So what we are doing is we are calling again a native contract that exists on every Bitcoin-IPC subnet, and we are telling it we want to transfer from this source subnet, that's the one where we deployed our token, to this second subnet, from the source address of user 1 to user 2, 5 USDT. This is 5 with 18 decimals. Once we submit this, now behind the scenes, two things have to happen. First, the validators of subnet 1 are picking up the transaction. They are signing again a message that says the user has transferred this amount to subnet 2, and this message is posted on Bitcoin. Now, on the other hand, the validators of the subnet 2, which is running, they are constantly monitoring Bitcoin, as we have also seen earlier. There is something called the Bitcoin monitor, and they can read all these messages. Once the subnet 2 creates a checkpoint, we will see here in the logs of the monitor that it detects an incoming transaction on this custom ERC20 token. The validators are verifying that indeed this comes from subnet 1 because they know the address of the validators and they can check their signatures. And once this happens, we can go on MetaMask and see that actually user 2 has received the funds. We have now waited a few blocks and subnet 1 has finalized and written this message on Bitcoin. As we can see, the balance of the user 1 has been decreased. And in the meanwhile, the validators of the subnet 2 have received the message from a finalized Bitcoin block and processed it and verified it. We can repeat the query metadata that we sent before to subnet 2, and what we can see is that now automatically subnet 2 has created a wrapped contract which represents the stablecoin that we defined before. We can use this and check what the balance of user 2 is. So let's switch MetaMask to user 2 in subnet 2 this time, and we can import this new token. And as we can see, user 2 has received 5 USD tokens. We can also send yet another transfer. Let's repeat the same process. We are submitting again a command to transfer from user 1 to user 2 another 5 USD tokens. We need to wait for some time for the same finality to happen from subnet 1 to Bitcoin, from Bitcoin to subnet 2, and then we should see that user 2 has 10 of the tokens and user 1 will have 0. And indeed, at height 946 of Bitcoin, we can see that the balance of user 2 was updated. And if we switch to user 1 and query its balance on subnet 1, this is 0 of our new tokens. And for completion and clarification, we can also now create a second contract Now we can call it token 2 with a symbol with 8 decimals maybe this time. And we can verify that indeed this is a different contract and it does not interfere in any way with the existing one. So this is under this address in subnet 1, we can import it. It's not recognized yet. Okay, maybe we have to wait a few seconds for the command to be finalized. On the subnet, here it is. It is a separate token, right? And of course, if we go on subnet 2, there is no representation of this yet, as we saw before, because it hasn't been transferred to that subnet yet. And this completes our demo. We saw how Bitcoin-IPC allows ERC20 contracts to be deployed on one subnet, which we call home subnet, and then without requiring the issuer to contact any other subnets or doing anything else on the other subnets, this token becomes automatically available on any other Bitcoin-IPC chain once a user transfers some amount of this token. Thank you for watching.